David Smith here with one more flipped classroom math lesson. 3 tips. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with your notes or jot down some questions. Third, you can turn on the captions and read my words on the screen. Today's lesson is going to cover this thing called the quadratic formula. And my comment about this formula is that when you go on in life, if you don't do math, like most of you won't be doing math, you still might remember that there's this thing called the quadratic formula, and it's kind of complicated and has a square root in it and all that kind of stuff. So first today, I want to show you where it comes from and how we get it. So let's take a look. Here is our general form, our standard form of a quadratic equation. It's set equal to 0. And up till now, what you've done is you've solved it by factoring or by completing the square on whatever these terms are, whatever the A, B, and C terms are. And you've worked that and you've found the solutions. Now here's the thing. This is one equation in one variable. So we can solve this equation for x. And if we get x alone on one side, everything else on the other side will be the solution. And so that's what we're going to do here. We're going to generate a formula. So the trick here is that we're going to leave A, B, and C just as they are and rearrange this equation so that x is alone on one side. So let's get started. First thing, I'm going to subtract c from both sides. ax squared plus bx equals negative c. Just like that. Pretty straightforward. Now I've got an a in front of my x squared term. Ultimately, I'm going to need to take the square root of this x squared. So first off, I need to get the a away. So I'm going to divide everything by a. And I'm going to get x squared plus b over ax equals minus c over a. So getting a little more complex, but pretty straightforward. Now, if you remember your complete the square process, that's what we're going to do. Now we're going to take our b over a and figure out what thing will complete the square with this side of my equation. So if you remember from completing the square, we take the b term, we divide it by 2, and we square it. So as a little side journey, we're going to do that. b over 2a is the same as 1/2 of b over a. So there's b over 2a. And we square that. So that's going to give us b squared over 4a squared. Just like that. I'm distributing my property on the top and the bottom of this fraction. So now I'm going to add this to both sides of my equation. X squared plus b over ax plus b squared over 4a squared equals minus c over a plus b squared over 4a squared. Now that's getting kind of complicated, but we can manage that. So just buckle your seatbelt and follow along. This side is going to be our perfect square. So now we can just simply write x plus b over 2a parentheses squared. So remember the b over a or the b term here is b over a. So it's 1/2 of that, so that's b over 2a. That's 1/2 b over a. So on this side, I need to combine both of these terms. So what I'm going to do is I'm going to multiply this term by 4a over 4a, and that will give us common denominators. So I'm going to rewrite that like this. 4a over 4a, that's just 1 times minus c over a equals that. And then we have our plus b squared over 4a squared. Getting complicated. So let's bring this down. X plus b over 2a squared equals, this becomes minus 4ac over 4a squared. And we have our plus b squared from here. So now I have one fraction. Okay, I was running out of space on the board, so I took that last step, brought it up to the top, erased everything else so we can continue. Now, if you remember from the beginning, I mentioned that we would be taking the square root to get rid of our squared term. So indeed, I have one side here is just squared. So it's pretty easy to take the square root. I'm going to get x plus b over 2a equals, now I have a plus or minus going on because I'm taking the square root of this, so I'm going to get plus or minus the square root of, and I'm going to switch the order here. That's a positive, so I can just write b squared minus 4ac over 4a squared, like that. Now, I can simplify this, and I can bring this over. So let's do that. X equals minus b over 2a plus minus. Now, the bottom, this is a perfect square. 4a squared is just 2a. So the bottom of this is just going to become 2a. And my top, I'm just going to keep my root, b squared minus 4ac. So now I think you can see I have two denominators that are the same. I can combine this side into one fraction. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this is the quadratic formula. So if you have a quadratic equation in ax squared plus bx plus c, you can take the a, b, and c and put them all into this, and it will kick out the answers. Okay, let's do one so I can show you that it works. Here is a real straightforward factoring problem. What two numbers multiply to 12 and add to 7? And they are 3 and 4, so I get x plus 3 times x plus 4 equals 0. And our answers are negative 3 and negative 4. So that's really quick. Okay, now let's use the quadratic formula to do this same problem, and let me show you how that works. So this is x equals minus b, that's a minus 7, plus or minus the square root of b squared, that's 7 squared, minus 4 times 1 times 12, just like that, all over 2 times 1. So that's the plug-in step for our quadratic formula from the last board. So let's simplify this on down. X equals minus 7 plus or minus. Now let's simplify what's in there. This is 49 minus 4 times 12, which is 48. So 49 minus 48 is 1 all over 2. Now the square root of 1 is just 1, so this becomes negative 7 plus or minus 1 over 2. Now that's going to give us negative 7 plus 1 is negative 6 over 2. That gives us 3. And negative 7 minus 1 is negative 8 over 2. And that gives us negative 4. So those are our two solutions, just like we got that way. Now, with the quadratic formula, you wouldn't use it to solve this one, because one glance at that shows you that you can factor it nice and quick, get your solution in just 2 steps. This has a lot more opportunities to make little mistakes and get the answer wrong. However, there are quadratics that are completely unfactorable, and this method will actually be the way to solve them. All right, let's do this one. 3x squared plus 6x plus 2 equals 0. Here's our quadratic formula. Now, a quick glance at this shows that it's a split the middle term type factoring problem, if we can do it that way. Our a term is not 1. So we multiply the a term times the c term and get 6. Now we're looking for 2 factors of 6 that also add up to the b term, which is 6. And we can't do that. There are no 2 integers that multiply to 6 and also add to 6. So we cannot factor this one. Now you could complete the square, that would give you a solution, but we can also go straight to the quadratic formula and find our solutions that way. So let's do that. Here's my a is 3, my b is 6, and my c is 2. So we just plug into our formula, minus 6 plus or minus the square root of minus 6 squared minus 4 times 3 times 2. There's the top, and then the bottom is just 2a, which is 3. 2 times 3. Okay, now let's crunch the numbers. That's going to be minus 6 plus or minus the square root. 36 minus 4 times 3 is 12, times 2 is 24. 36 minus 24 is 12, all over 6. Now, you're on the hook to simplify your roots. So let's just take one more step there. Negative 6 plus or minus Now 12 is the same as 3 times 4. 4 is a perfect square. It comes out of the root as its square root, which is 2. So that would be 2 root 3 for the root 12 all over 6. This is all x equals. So we can finally finish that by reducing this down. That becomes a minus 3, and that goes away, becomes a 1. So we get minus 3 plus or minus root 3 over 3. And that's the answer. So we have two solutions here. We have negative 3 plus root 3 divided all by 3, and negative 3 minus root 3 divided all by 3. Now, this is an exact answer, so follow your prompts. If you have a test question that says to 3 sig figs, then you do want to figure out what root 3 is and resolve this fraction. If it says exact, you're done. All right, let's do a couple more problems and then I'll let you go. So check this out. 6x squared equals 7x plus 5. What's your first step going to be? Right, you need to put this into general form. And right now we're not there. So we're going to subtract 7x and 5 from both sides to move them over to the left-hand side to get 6x squared minus 7x minus 5 is equal to 0. Now check it out. Here's your A, your B, and your C. So we're going to go ahead and plug that into the quadratic formula. I've got minus B. I like to do a pure plug-in step. Now you could in your brain go, oh yeah, that's going to be positive 7, and just write down positive 7. But believe me, I see people make mistakes when they get into that habit. I really try to do a completely pure plug-in step and then start thinking about the math involved. So minus negative 7 plus or minus the square root of minus b, or of b squared, that's negative 7 squared, minus 4 times 6 times negative 5. Just like that. And then put that all over 2 times my a, which is my 6. So there we go. Now let's remember it's equal to x. So I'm going to reduce this down a little bit. All right, so I'm going to go ahead and handle this in a few more steps than last time just because it's got bigger numbers to deal with. So I'm just going to add an equals there and go 7 plus minus the square root of 49, that's negative 7 squared, minus, now I have a minus and a minus, so this is actually going to become plus, and 4 times 6 times 5 is 120. So we're going to get 49 plus 120 under my root, and then this is all over 12. Okay, so let's take this a step further. X is going to be 7 plus or minus the root of 169. That should have your attention. Over 12. Now, 169 is a perfect square. It is the square of 13. So now I can get 7 plus or minus 13 over 12. So now I have what I like to call the branch. I have 7 plus 13 over 12, so let's do that one first. 7 plus 13 divided by 12. That's going to give us 20 over 12, which is 10 over 6, which is 5 over 3. So there's one of my solutions. My second solution is going to be 20 minus, or 7 minus 13 over 12. And that's going to give me minus 6 over 12, which is negative 1/2. So my solutions for this one are very fractiony, 5/3 and minus 1/2. So don't let the fractions get you discombobulated. Just use your brains and you'll solve them. All right, let's see how you did. I did my plug-in step there. I just put in my B, my 4 from the formula, my 1 for my A, and my 5 for my C. I worked my numbers down. I get 4 plus or minus root negative 4 over 2. I want to take you that far. Go ahead and finish it. Okay, that was a trick question. Root negative 4. We don't do that. This is no solution. Sometimes we write that as the empty set. You might see that somewhere. We also use a handy abbreviation, NRS. That means no real number solution. There is an imaginary solution for this function, but it's not something we can graph on the coordinate plane. Now, what does this mean? This is a parabolograph. Perfectly fine parabola. If you put that in your calculator, you're going to see a great little graph. It's no big deal. But what does it mean that it has no solutions? Think real hard. What kind of parabola would have no solutions? Do you remember what the solutions are? They're the x-intercepts. So any of these parabolas could be this one. We know this is positive, so it's not down here, right? But these also have no solution. They just don't cross the x-axis. In other words, y never equals 0. For all 5 of those parabolographs, y doesn't equal 0. So this equation, notice how we set it equal to 0. This is y, this is f of x. It can't be 0 for these 5 graphs that I just put up there. So that's all that means, is no x-intercepts. Now that you've watched the video, take a moment to jot down some notes, some questions, or a quick summary of the content. You can also re-watch the portions of the video that were a little bit challenging. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.